All right. So hello and welcome everyone. So we are live right now. So I welcome all of you to this amazing platform of Tutee Learning JEE. And today let us continue with our ongoing discussion on parabola, right? So if you have recalled, then we have started with parabolas in our last discussion, right? So if you are new to this particular platform, I would request you to please go back and watch the previous lecture before you start to watch this current lecture, right? Because without watching the previous lecture, it won't be very useful to understand the connectivity of this particular connection topics, right? So in the last class, we discussed about how can we formulate any general conic sections, and along with that we saw how to write down the standard equation of any parabola, right? So that was what we did in our last class. So in today's class we are going to discuss some of the question regarding the standard equation of the parabola, and along with that we are also going to solve some of the problems, right? So let us start. So today let us start or begin our class with a small recap on the previous topics with a use of a simple problem, right? So let me start our class with a simple problem. Alright, so the question is on the screen over here. So let us try to understand what is this particular question trying to solve, right? So if we look at this problem, it is asking for find the equation of the parabola which is having its vertex at point A, which is given as 1, 0, and the focus is given at 3, 0. So if we talk about the first problem, it is saying that you have to write down the equation of the parabola whose vertex is given as point A is equal to 1, right? So sorry, whose vertex is given as capital A point, and that is 1, 0, right? And the focus, which is given as S, the focus is given as 3, 0, right? So if you recall the distance of the, so in a standard equation of a parabola, like y square is equal to 4ax, which we have discussed in our last class, we saw that the vertex of this particular parabola is at the origin 0, 0, and the focus is at point A, 0. That means the distance of the vertex from the origin is basically the distance which we call as A. In this parabolic equation, this parameter A is basically the distance of this focus and this vertex. So if I try to find out this distance of A and S, it is going to be simply 3 minus 1, that is equal to, and that particular value is equals to the value of A, right? And also if you recall, in this kind of parabolic equation or standard equation of the parabola, the vertex is at 0, 0. But in this case, the vertex is at point 1, 0. So if I do a transformation like x minus 0, then in this transformation, when I transform x with x minus 1, in this case, my modified vertex is going to be at 0, 0. Therefore, the modified equation of the parabola is going to look like something like this, right? So this is my modified equation of the parabola, right? And in doing so, what I obtained is that therefore the equation of the parabola will look something like this. Okay, so this is going to be the equation of the standard parabola, which is having the vertex at 1, 0 and the focus is at 3, 0. I hope this is clear from the previous discussion. So this is what we do over here. So this is simple coordinate transformation. Okay, so whenever we will have the vertex to be somewhere else, we'll just need to perform some coordinate transformation in order to get to the required or the standard form of the parabolic equation. I hope this is clear to all of you, right? Similarly, if we talk about the second problem, so first problem is done. So if we talk about the second problem, it is said that the parabola is having its focus at 2, 0 and one of the extremities of its latest rectum is at 2, 2. Right. So if we recall, in our last class, we've been discussing with the geometrical properties of the any general conic section, and we saw that for a parabola, the lattice rectum is basically a perpendicular chord, or I would say it's a double ordinate which is passing through the focus. So here we have the focus 2, 0. So if I draw a double ordinate like this, where the endpoints are A and B, then my A and B line is called as the lattice rectum, right? So this is what we have seen in our last class, right? So this is my lattice rectum, and it is said that one of the extremities of the lattice rectum, so let us say this is the x-axis and this is my y-axis. So one of the extremities of the lattice rectum is given as 2, 2. So we have to find out the equation of that particular parabola. So we recall that this length of this lattice rectum was given to be as 4 times of A. If you don't know how to calculate that particular lattice rectum, let us try to take it up. So if we have the standard equation of the parabola like this, right, which is basically given as y square is equal to 4ax, the focus is at a comma 0. So if I try to draw a perpendicular line passing to the focus, it is something like this. This line equation will be going to be x minus a equals to 0. And if I solve for x minus a is equal to 0, I will get the value of a as, or y as, plus or minus 2a. So the values will be a comma 2a and a comma minus 2a. So this is a perpendicular line to the x-axis. The distance of this particular line is going to be simply equal to 4a. So this 4a parameter is going to denote the length of the lattice rectum. So over here, in this case, my AB distance is going to be equals to, so 4 over here, right? So similarly, the other extremity will be 2 comma minus 2, right? So we will have the length of the lattice rectum as equals to 4. So the length of the lattice rectum is equals to 4, and in this case, I can formulate the equation of this this particular parabola whose vertices are basically whose focus is basically 2 comma 0 and the extremities of the lattice rectum is 2 comma 2. Then this particular equation can be written as y square is equals to 4x. Y square is equals to 4x. Okay, I think I'm doing a mistake over here. But in this case, you have to take a note that our vertex is basically at 1 comma 0, right? Because our a is going to be equal to 1, right? So the vertex is at 1 comma 0. Okay. I hope this is clear to all of you. Right. In a similar manner, if I talk about the third problem says that this particular parabola is having its focus at 0 comma minus 3 and the directrix at y is equal to 3 line, right? So let us try to attempt the third problem. So if we try to talk about the directrix, so we have been discussing with the directrix of any conic section is basically a perpendicular, is basically any straight line, any fixed straight line, right? Sorry. So in this case of our parabola, so in this case the directrix is given as y is equals to 3, which is basically this line, right? So, and it is also mentioned that the focus of this parabola is lying on the line 0 comma minus 3. So this parabola is going to be oriented towards a negative y direction, something like this, right? Now, in order to find out this equation of the parabola, what you can do is simply you can find out that by the locus equation, right? So if you imagine any point P as x comma y, and let us say this is my directrix. So the distance of this point P from the directrix should be equal to the distance of this particular point from the focus, right? So your PS should be equals to PM distance, right? So if you are able to satisfy this particular relation, then you are easily able to get to the equation. So if I do that, I will be getting, so this is the PS distance is equals to the directrix distance is going to be y minus 3 whole square, right? Because I'm taking square on both the sides. So if I simplify this part out, I'm going to get the equation of the parabola to be coming out as y square is equal to minus of 12, right? Y square is equal to minus of 12, which is again very simple because the directrix is basically obtained at, so in this case the directrix is basically at y is equals to a. So in this case our value of a is equals to 3, right? But this parabola is downward opening, so the parabolic equation should be equals to minus 4a is equals to x square, right? And the focus is as 3. So this particular length is also equal to a. This particular length is a. So if I solve this, I'll get x square is equals to minus 12y, right? So this is going to be the standard equation of the parabola, right? So we can also solve by definition and we can also solve by the standard equation. So since in this case the eccentricity is equals to 1 for a given parabola. I hope this is clear to all of you. Is this part clear? I hope this is clear, right? So this was basically a basic discussion on the standard equation of the parabola. Okay, so if you have any problem, please do let me know so that we can discuss on it, right? All right. So let us move forward with our next discussion and let us move towards understanding some more problems, right? So some more interesting problems, let us try to discuss on it, right? So let us say now these kinds of problems are very crucial, especially for your JEE mains examination. Okay, so it is very important to understand this problem before we start to go on or move on to different topics, right? So if you recall, in the last class we have been also discussing with the another format of equation of parabola, that is something called as the parametric form of a parabolic representation, right? So in the parametric form of any standard parabola, let us take a standard parabola like this, which is given as y square is equals to 4ax, right? For this standard parabola, if I want to denote any point P in terms of parameter, that can be given as 80 square comma 280, right? So this is what we called as the parametric form, right? So this is called as a parametric form where T is my parameter, which can be any real number, right? So this question is going to be an simple illustration of how we use the parametric form of the uh, parabolic equation, right? So it is said that an equilateral triangle is inscribed inside the parabola, which is a standard parabola, such that one of the vertex of this triangle coincide with the vertex of the parabola. Then find the length, side length of the triangles, right? So if we look in the problem, it is said that the vertex, so this vertex is origin, is coinciding with the one of the vertex of the triangle, right? So let us say the triangle is something like this. Let us call this point as A and let us call this point as B point, right? So in this case, what we'll obtain is that, so we will have this triangle AOB is the required. Now in this case is mentioned it is the equilateral triangle, right? So it is going to be an equilateral triangle in this case over here, so that we will have all these angles is going to be 60 degree, right? And the length of the sides are also going to be same. But how am I going to determine that what will be the length, right? So since it's an equilateral triangle, this particular triangle should be symmetric, and since parabola is also symmetric about this x-axis, so in this case to inscribe an equilateral triangle, this should be an equilateral, this should be an symmetric case, right? So we'll have this particular angle to be 30 degree, right? So in this case I can easily formulate for point A, since it is angle is 30 degree, so point A can be easily given in terms of some parameter, that is root 3 by 2 p comma p by 2, right? So this is how we can represent the coordinate of A. And in the similar manner, since the coordinate of B should lie exactly opposite of A, so the coordinate of B can also be given as root 3 by 2 p minus of p by 2, minus of p by 2. So this is what we will have, right? Now since the parabola, that is the point A, is lying on the parabola, so point A is lying on the parabola, so if you satisfy this in the parabolic equation, I will get p square by 4 is equals to 4a times of root 3 by 2p. So from here we can easily formulate for the value of p, and that will turn out to be, so p will turn out to be 8 root 3a. So the value of p will turn out to be 8 times root 3 by a. Alright, so with this value of p, we can easily say the length of the side. So the length of the side, that can be OA, can be easily formulated, and that will be basically so we will have square root of, so we will have the length of this any side will be square root of 3 by 4 p square plus p square by 4, that is going to be equal to p, and that is basically going to be equal to 8 root 3 a. I hope this is clear to all of you, right? So the length of the side is going to be 8 root 3 a. Okay, so these are very interesting problems that we need to discuss to understand how we move forward with following discussion of this chapter, right? Along with that, now if I change this triangle to a quadrilateral problem, let us say I change this triangle to a quadrilateral. Okay, so let us now inscribe a quadrilateral inside a parabola. So how will this problem change? Let us try to discuss. So a quadrilateral is inscribed inside a parabola, and the parabola is this standard parabola, such that the three of its sides passes through the fixed points on the axis. So you have to show that the fourth side also passes through the fixed point on the axis of the parabola, right? So we will have over here, let us try to draw the parabola first of all. So this is my x and the y axis, okay, and the parabola, let us try to draw the parabola something like this, okay. So the parabola is something like this. What we have to prove is that the fourth side of the parabola, is actually passing through the point, passing to the fixed point on the axis, right? So what we try to do over here is that we have said that the quadrilateral is inscribed inside a parabola. So let us take some 4 points in this parabola, right? So let us say this is A point. Now we have been discussing that all the points can be given in terms of parameter. Let us call the parameters T1, T2 and T3 and T4, right? So this is my 4 points which are inscribed inside the parabola, right? So these are my 4 points which are inscribed inside the parabola such that this is my quadrilateral. So A, B, C, D is my required quadrilateral, right? Now if we try to move forward with this problem discussion, what we can go on and do is that, so let us try to find out first of all. So it is mentioned that the fourth side, so we have to take the fourth side and we have to show that it passes to the fixed point on the axis of the parabola. So this is the axis and the fixed point of the parabola, you have to show it that, right? So before we do that, let us first try to get the equation of the chord of AB. So any equation of the chord AB can be given in terms of parameter T1 and T2, and if you solve it, it will simply turn out to be 2x minus T1 plus T2y plus 2a T1 T2. Okay, so this is going to be the equation of any chord of a given parabola, which can be easily found out because you know that point A is going to be at1 square comma 2at1. This is my point A, and similarly I can obtain my point B as at2 square comma 2at2, right? So from here the equation of the line can be given as y minus 2at1 is equals to slope times x minus that point. So slope will be t2 minus t1, 2 times of that divided by, so a will be cancelling out, so I'm simplifying it up and writing it over here. So and then we have t square minus t1 square. So if you simplify this part out, it is going to come out as 2 upon t2 plus t1 times x minus a t1 square. So if you simplify this part out, you will be getting the equation of the chord of AB is going to be something like this: 2x minus t1 plus t2 y plus 2a t1 t2 is equals to 0. So if we have to show that this, since this passes to a constant point, so let us take the constant point or fixed point on the axis c comma 0. So if this point A, if this line AB passes through this constant point, then I can show it, since it passes through c comma 1, c comma 0, so it is equivalent to showing it. So if we do that and put it over here, so we'll get T1, T2 to come out to be minus of C upon A. So T1, T2 should come out to be minus of C upon A. In a similar manner, if my chord BC passes through this fixed point, so this for AB, since if I do the same thing for BC, if it passes through C comma 0 or a fixed point, or let us say that particular fixed point is D comma 0, right? So in this case, we will obtain T2, T3 as D upon A, right? Sorry, minus D upon A. And the similar case, if I say that CD passes through the fixed point, let us say E comma 0, then in this case, we will have T3, T4 should be minus of E upon A, right? So we are doing it by the similar analysis, right? And now if I multiply all these three equations, so this is my first equation, this is my second equation, and this is my third equation. So you multiply all together, then I will going to get T1, T2, T3 and T4 should be equals to plus of EC upon A square, EC upon A square, right? This is part clear. So you multiply all together, we will get upon EC upon A square. Now we know that T2, T3 can be given as minus of D upon A. So if I put it over here, then I will get T1, T4 as minus of EC upon AD. T1, T4 to be coming out as minus of AC upon AD. Therefore, I can say that since this particular T1, T4, which is basically in the equation of the chord of AD, so in the equation of the chord AD, it will come out as, So in this case, this T1, T4 should be coming out as minus of EC by D. Therefore, that basically means that it passes through one fixed point. It passes through one fixed point whose coordinate is minus EC upon D comma 0. Alright, so I hope this is clear to all of you. I hope this is clear. Is this part clear? So this is how we can solve for different types of problems that we can encounter. Okay, so this problem is quite an interesting problem to understand about how do we write down the equation of a chord of a given parabola, right? Alright, so let us now try to focus on some of the other aspects of geometrical aspects of a parabola, right? So this lecture is quite of an basic lecture for discussing about the basic questions on the parabola, right? So in the next lecture, we are going to discuss about the other important relevant theories, right? So the question is mentioned as a right angle triangle is inscribed inside a parabola where A is the vertex of the parabola and this angle PAC is given as pi by 2. And you have to find, and it's also given that the length of AB is given as root 5. So with that particular discussion, you have to find out that what is going to be the area of the triangle ABC. Okay, so please try to solve this problem. It's a very simple problem. So let us try to see how we can solve this problem, right? So again, let me draw the coordinate axis. So if this is my coordinate axis such that this is my standard parabola, which is given, the equation is given as y square is equal to 4ax, right? So with this, we will have the focus at 1 comma 0 and the vertex is at 0 comma 0, right? And it is said that the A is the vertex of the parabola and it is triangle ABC. So triangle ABC such that this particular angle is going to be 90 degree, right? PAC is going to be 90 degree, right? And it is mentioned that this AB line is given as, the length is given as root 5. So we have to find out that what is going to be the area of this triangle ABC. So with this discussion, let us try to denote the point B as in terms of parameter 2a, t square comma 2t, right? Because a is equals to 1. So t square comma 2t is going to be coordinate of B, and the coordinate of C, let us call it as t1 square comma 2t1. Okay, so t and t1 and the two parameters, right? Now also we will know that since the length of the side AB is given as root 5, so from here we can simplify this AB distance in terms of parameter t and we'll obtain a relation as this as follows, right? So from here I can easily simplify this quadratic equation in t square. So from here I will get the value of the parameter t as plus or minus 1. So this point B is going to be 1 comma 2, 1 comma 2, and since it is a perpendicular at point A, so the slope of this line AB multiplied with the slope of the line AC should be equals to minus of 1 since these are perpendicular lines. So using this particular fact, and the slope of the any point is given in terms of 2 upon t multiplied by 2 upon t1. So this is slope of line AB and this is slope of the line AC, and this is going to be equal to minus of 1, right? So if I solve this relation, so from here I will get t1 t2 should be equals to, so t1 t2 should be equals to minus of 4, right? So t1 t2 should be equal to minus of 4. So from, sorry, tt1, right? So we have tt1 should be equals to minus of 4. So from here your t1 should be equals to minus of 4 because t is equals to plus of 1, right? So therefore the coordinate of point C is going to be 16 comma minus of 8, 16 comma minus of 8, right? And in this case, therefore we will also obtain the length of the side AC, which is going to be equal to 256 plus 64 and square root of it, just simply using distance formula, and will obtain the results to be root under 320, root under 320, and therefore the area of this triangle ABC can be easily obtained as half times length of the base into perpendicular, right? Since it's a right angle triangle, so this is going to come out to be equals to, this product is going to be 1600 divided by 2, which is going to be equal to 20. So 40 upon 2 is going to be 20. So 20 square units is going to be the correct answer. Okay, I hope this is clear to all of you. I hope this discussion is clear. Is this part clear? Please do let me know in the live chat. Is this clear or not? Is this part clear? Right. So let's try to move on to the next problem. Okay. Also, let us try to discuss about another important concept, that is the position of a point with respect to the parabola, right? So in the chapter of circles, we also discussed about that when is the point lying inside the circle or outside the circle, how do we determine it using the parametric notation or the notation of the equation of the conics, right? So with regard to that, let us try to discuss about position of a point, position of a point with respect to position of a point with respect to a parabola, position of a point with respect to a parabola. Okay, so let us try to discuss about the position of a point with respect to a parabola, right? And the parabola, let us take the parabola as a standard parabola, that is y square is equal to 4ax. So if I try to draw that, the standard parabola over here, okay, so this is my standard parabola, y square is equal to 4ax. Now if I take up any point, let us say this point is P, which is given as x1 comma y1. In order to determine that whether this point lies on the parabola or outside or inside, what I'm going to draw, I'm going to draw a straight line. So in this straight line, this point, this perpendicular line, this Q point is going to lie on this parabola, right? And let us call, since the x is going to be, x1 is going to be same, the y is going to be different, right? So this y, let us call it as y2, right? Where y2 is going to be equal, y2 square is going to be equals to 4 times of ax1, right? And the perpendicular drop on the axis is going to be x1 comma 0. So let us call that point as m, right? So if we have this discussion now, since from looking at this problem, since this point P lies outside this parabola, therefore what we can say is that if my point P lies outside the parabola, this PM should be greater than QM if it is outside, right? So if I do that analysis, if I take the square, it will also be greater, right? So therefore if I do this analysis, what I will get is that I'll get y1 square is going to be greater than y2 square, right? And we already know the value of y2 square, that is basically, so I can write y1 square to be greater than 4 times of ax1, and that basically can be written as y1 square minus 4 times of ax1 to be greater than 0. So therefore if the value of the equation of the parabola at that point x1 y1 is greater than 0, then it is outside of the parabola. That is how we define the region of the parabola. Okay, so therefore we call this as outside of the parabola. In the similar manner, we represent it in circles. So let us call this equation as S. So if your S is greater than 0, it is outside. If your S is equals to 0, it is on the parabola. And if your S is less than 0, it is inside or interior. Okay, so this is how we represent the position of any point with respect to a given parabola. I hope this is clear to all of you. I hope this is clear. Okay, so this is how we are going to denote or the relative position of any parabola with respect to the point. Okay, is this fine? Is this fine to all of you? Okay, so in the next class, with this particular understanding, we have almost discussed about the quite an important understanding of the very basics, and so therefore we are now ready to discuss about any general equation of a parabola, right? So in this any general equation of parabola, we might also have terms containing x and y, right? The coefficient of the terms x, y. So how are we going to deal with any general equation of parabola? That is, we are going to discuss in our upcoming lecture. So stay tuned for that, and we are definitely going to discuss about how to recognize that different conics, right? For example, if you are given the general conic equation that we have studied, that is ax square plus 2 times of hxy plus by square plus 2 times of gfx plus 2 times of f of y plus c equals to 0, right? So this is what we have seen, right? And from here we have also taken up one important parameter, that is delta, right? which is basically this determinant, right? So this determinant is not equal to 0. That basically means that these are the non-degenerate conics, right? So if it is not equal to 0, then we have been discussing that these are the non-degenerate conics, which are circles, parabola, non-degenerate conics. Okay. Whereas if it is equal to 0, then this is the case of degenerate conics, which is basically the pair of straight lines, point, right? So those all things are basically degenerate conics, right? So in this particular chapter, we are also going to understand how can I recognize that what kind of conics is there from a given this kind of conic equation, right? So that is also we are going to discuss in our next class. So in next class, we are going to discuss about the general equation of the parabola, and we're going to solve some more problems representing those types of equations, right? So with this, I thanks a lot for all of your attention, and I hope to see you soon in our next class. With that, I wish you